All right, now for the promised derivation of the law of cosines. So where does this formula come from? All right, so the first thing we want to do is look at our generic triangle, right? It works for any triangle. We'll label the parts, angle A, B, and C in orange, and then in pink we've got the opposite sides, right? Angle A opens up into side A, angle B opens up into side B, and angle C opens up into side C. So we're actually going to get a law of cosines that looks a little bit different than the formula we used in the last video. We had this. You'll notice the triangle is the same, but I gave you the formula with c squared on the outside and c here. So it turns out that when you do this, the way I'm doing it, you'll either get, with a and b down here, the way the triangle is oriented, you're going to get cosine of a or cosine of b. In this video, we'll be getting cosine of a, I believe, if I stick to my guns. And the idea is that, remember, we're randomly labeling these sides. I called these A, B, and C. I could flip them around if I wanted to. If I needed to, I could call this C, and then if I did the formula over, I'd have different letters in different places, but they'd mean the same thing, right? So we're going to get a formula that has these two matching here, whether they're both C's or B's or A's, doesn't matter, and then our leftover sides are going to fill in the rest, right? So that's the idea. Don't get fooled by the letters, and don't let that confuse you. All right, so what we're going to do first is we're going to drop an altitude, drop an orthogonal, drop a height. We'll call it height, or H for height. I'll label that now with an H. All right, so this is the height of the triangle. You can always do this for any triangle, and it does not necessarily cut it in the middle here. This is not a perpendicular bisector, so AC, or I'm sorry, this point right here, we'll call it, I don't know, how about D? This point can be D. All right, so AD and DB are not necessarily going to be equal, right? I could draw lots of generic triangles, and if I were to drop a height, right, while it would be 90, it would not be cutting this triangle into two pieces here. It would not be bisecting this segment right here. So do not assume that this is a bisection. That is not true. When we drop a height, all it does is guarantee that it drops at a 90 degree. Imagine sitting at the top of a cave and you're spelunking down to the ground, and you drop your rope, and your rope will always fall straight down due to gravity, and that straight down will mean it'll hit the floor of the cave at a 90 degree, something like that. Obviously, caves have slopes and stuff, but what do I know? I'm not a spelunker. All right, so we've dropped a height, we've dropped our rope down to the floor, it hit it at 90 degrees, it did not necessarily bisect this, so we're not going to label that. But what we are going to do is we're going to call this portion over here, we're going to call that X. So the length between A and D, we're going to call X. Well, if that's length X, and the whole thing we already labeled is side C, right? That's a length there, length of C. Well, if we take C, the whole thing, and we subtract this part, X, well, what's left over is this. So the whole thing minus this part gets us this part. So I'm going to write that. The whole thing, of course, is C. And if we subtract X from C, we get this side. So I'm going to call this side C minus X. How long is this side? It's however long C minus X is. So if C was 10 and X was 6, well, if that's 6, this has to be 4. And how do we do that mentally? Well, if the whole thing's 10 and that's 6, we can do 10 minus 6 and get 4. Otherwise known as C minus X. Again, if C is 10, we get 10. And if X is 6, we get 6 here. So 10 minus 6 is going to be the length, which of course is 4. So this is a way of getting around the idea that while this isn't a bisection, we can still label it and call it something. So that's kind of useful. So we have X and C minus X. So the first thing you're going to do, and I'll try to do that over on this side of the page, our little proof area, is we're going to do Pythag for both sides. So you'll notice that we've created two right triangles by dropping this altitude, right? We have a left side triangle and a right side triangle. I'm going to do the left side first. So Pythag for the left side would be the two sides squared and added together equals the hypotenuse squared. So when I write that, it's going to be, let me grab a green marker, it will be X squared plus the height squared equals B squared. So our height I did in purple, H, and I happen to do the hypotenuse over here, B, in pink. Hopefully that shows up for you guys, a difference there. I have to be careful, some of my purple markers are faded and come up pink. So I'll stick with these guys. So we have X squared, this bottom part, plus H squared, the other leg, equals the hypotenuse B squared. Okay, cool. So what we're going to do is we're going to get h squared on its own because we're going to need that for later. So this is kind of just looking ahead. If you didn't know that, if you're just going this freely, you'd notice later on that there's a good substitution you can make for h squared. And you need to get h squared on its own to do that. The reason we need to get rid of h squared eventually is because we added in this h, right, to our generic triangle. I want to remove it. That way all we need to know are angles and sides, right? Same thing with x. We're eventually going to remove that from our formula because I added that in. Again, all I want to deal with is the a, b's, and c's because that's what our formula looks like. There's no x or h in it. Right? It's just A, B's, and C's. So I need to remove the things that I added in. Those are just going to be tools for doing the proof. So let's get h squared on its own. And of course, to do that, we need to get rid of x squared, right? We need to move that over so h squared is on its own. So I'm going to subtract x squared from both sides. And when I do that, well, these cancel, and I get h squared. Oh, I told you. Some of my pens are pink, even though they're labeled purple. H squared. I wonder if that's a common occurrence with Sharpies. I see a lot of that in a lot of my purples, equals b squared. And so I have these two that stayed, right? I wrote them, and then I moved over the x squared. So now I'm going to write that in, minus x squared. So now I've solved the equation for h squared. H squared is b squared minus x squared. And we're going to save that for later. So save that, box it. We're going to use it later. All right, so the next thing we want to do is do Pythag for the other side. So we did for the left triangle. Let's do it for the right triangle. So in this case, instead of x being our bottom base, it's going to be a c minus x for that leg. So it's the quantity, because there's two terms here, a c and an x, of c minus x. C I did in pink, and x I did in green. And it's going to be that quantity squared, because that's our one leg squared, added to our other leg squared, which is, again, h. H I did in purple. And that's going to equal the hypotenuse squared. Well, the hypotenuse for the right triangle, the right side right triangle, is going to be a. So it's going to be a squared here. All right. So it's going to equal a squared. Now, we're going to mess with this little bit that we have right here. We're going to tease this out. We're going to expand this. We know that squaring a number is multiplying it by itself. So when we square a quantity, we're just multiplying that quantity by itself. So another way to write this would be c minus x times the quantity of c minus x plus h squared equals a squared. So let me write that out. I'm just turning this quantity squared into two binomials, c minus x times itself. Right? That's what squared means. Plus h squared equaling a squared. All right, so here we are. All right, so now we can distribute. C times c is c squared. So it's kind of cool. We get c squared when we multiply. Let me draw my little lines, right? C times c gets us c squared. And then we have c times negative x, which is negative cx. I'm going to keep the c out front, treat it like a constant, negative cx. And you'll notice if we're done distributing the c, now it's time to distribute the negative x. So we're going to get another negative cx. Those later we will combine because they are like terms. They have the same variables. All right, and then lastly, we need to distribute the negative x to the negative x. Again, don't miss those negatives. They stay with the x. So we have negative times a negative is a positive. So it's going to be positive x squared. X I was doing in green, it's squared. And that's going to equal, or I'm sorry, add to h squared is going to equal a squared. So I've got my h squared over here and my a squared over here. Okay, cool. So all I did was take this equation and I took this part right here, I'll highlight it in blue, and I rewrote it as this, which was originally this guy, right? So I took the quantity of c minus x squared, I expanded it, made it c minus x times c minus x, that's what squaring means. I distributed, and I got this. So I'm going to take these things, you'll notice these two terms are the same, so I can combine them. It's kind of like saying I've got a dog and another dog, where I could shorten this by saying, look, I just have two dogs. So here's what I mean by that. So we get c squared minus 2 cx's, right? I could either say subtract cx and then subtract cx again, or I could say, just to keep it short, subtract cx twice, right? 2 cx's, subtract 2 of them. So let's fill in all the rest of our stuff. Oh, I had 2 on there twice for squared. we have a squared, we've got h squared, and we've got another x squared here. All right, so we've done all we can do with this little blue part right here. We've expanded it out as much as we can, and I wrote another squared. People at home are cringing. So that's just x squared. All right, so what we're going to do is we're going to refer back to this thing, and we're now going to substitute h squared out for that orange part from before. So we know that h squared is b squared minus x squared. So this is good because it gets rid of our h. We're not going to have an h in our formula anymore. It's still going to keep x's, but that's okay. We're going to work those out. So what we're going to do is substitute for h squared, b squared minus x squared. So everything's the same. C squared minus 2cx plus x squared. And then instead of plus h squared, we're going to write plus b squared minus x squared equals a squared. All right, let's see if I did this outline correctly. I'm trying to, again, be efficient here with my colors. So c and a, and then we've got x and x squared. And instead of h squared, we were going to have b squared minus x squared. All right, so I took h squared and I substituted it for this, right? We said h squared is equal to b squared minus x squared, so I just switched them out. If I told you h squared was 5, well, you could have plugged in 5 for h squared, right? But I told you h squared was b squared minus x squared, so you can plug that in. You'll notice, hopefully, right away that we have a positive x squared and a negative x squared, and those are going to cancel, right? A positive x squared, if we add x squared and then we subtract x squared, it's like we did nothing, so why even write it? So we're going to cancel those terms and get c squared minus 2cx plus b squared, because that x squared and x squared are going to cancel, and that's going to equal a squared. And I already goofed up one of my colors, so let's make that a pink b as best as I can. There we go. And we have c and x. So again, these two guys, the positive x squared and the minus x squared, cancel, and now we just get what's left over. So this stayed, this got canceled, this stayed, and this stayed. So as you can see, we're pretty close to getting something that looks like p-fad. We've got an a squared, a b squared, and a c squared. I'm going to rearrange that just so the c squared and the b squared are next to each other. So both are positive. So I'm going to be adding c squared and b squared here. And then I'm going to put the minus 2cx afterwards. So c, a squared, and let's do a cx. Okay, cool. So all I did is I rearranged this. I put the b squared before the minus 2cx. So I have c squared and b squared being added together, and then I have the minus 2cx following. Let's scoot up and make a little bit more room. All right. Oh, caught on something. All right, so now we're here, and we need to get rid of x. It's the last thing we need to get rid of before we have all a, b's, and c's. So refer back over to our diagram. Here's x. We also need a little bit of cosine, because this is the law of cosines after all. So we need something with cosine in it that refers to this side here, this side x. So what we're going to do is we're going to take the cosine of one of these angles, either A, B, or C, and that angle is going to have something to do with x. It's either going to go on the top or the bottom. Well, we know the cosine of C isn't possible. That's not going to get us x. X is the opposite side to any of the angle C's that we have here. We do have two of them. If we did B, well, it's in this triangle, so the adjacent cosine of B would get us this, tangent of B would get us this over this, and sine of B would get us H. That's not really going to help. But if we look at angle A has to do with X because they're in the same triangle. And we know the cosine of angle A is going to be X, right, the adjacent side, over the hypotenuse. So we have X. Going to equal x over b. So now what we want to do is we want to get rid of this x. So we need to get x on its own so we can switch stuff out, just like we got h squared on its own earlier, right? We got it on its own so we could switch things out. Now we're going to get x on its own here. That way we can switch this x out for whatever, switch this x out for whatever this equation turns into. So what am I going to do? Well, to get x on its own, b needs to be moved over. So it's currently being divided, so I'm going to multiply to move it over. And when I do so, I get b times the cosine of angle A, and that's going to equal, well, these cancel, and I get x. So x is b times the cosine of angle A. All right, so I'm going to take this right here, and I'm going to plug this in, this part right here, in for x over here. So let's do that. Let's scoot this over just a little, give myself a little more room. All right, so I'm going to plug in this right here into x. So I'm going to keep the c squared, I'm going to keep the b squared, I'm going to keep the c, and it's going to all equal a squared. So let's use our black marker now, minus 2c, and instead of that x, I'm going to plug in b times the cosine of a. Well, this is c times x, so it's c times b times the cosine of a when I switch it out. Squeeze that a in there. And now we have a formula that looks really similar to our law of cosines formula. I'm going to rewrite it over here just so you can see it in the more usual way of looking at it. You'll notice here we have a squared on the end. I'm going to write that first. So let's do a squared here equals, again, I'm saying all this equals a squared. I can then say a squared equals all that. So let's write that all out in color. C squared plus b squared minus 2cb. And then we can plug in our numbers. So c squared plus b squared minus 2cb cosine of angle A. And again, from earlier, we had c and c here and a and b's here. Well, the difference is that when we solved, we oriented our triangle in such a way that a was the bottom corner. And that bottom corner is where x is, so that's where cosine of a is going to come in. Whoops, sorry, let me move it so you can see it. So these are going to match, right? That's the key you need to look for law of cosines. Do these things match right here? They're associated. Here's angle A, and that goes across to side A. So of course they're going to go there. If I wanted to solve for angle B, well then I'd make these both B's, and instead of B's here I'd have A's. If I wanted to solve for angle C, like in our original formula, I'd have these both C, and these would be A's of these. So it's all about orientation. Don't be fooled. When you have to derive the law of cosines, oftentimes you'll be given a triangle that's already labeled. And the tricky part is if you memorize the version where it's C and C here, you get lost because you're not really thinking about what it actually means. A is going to be the angle what we're looking for because this x here is what's going to get us that cosine of angle A. So just a pro tip to look out for. Don't get confused by the letters. Try not to memorize it. See if you can do it with letters in all the different spots. Put a B here, put a C here, etc., etc. So that's the derivation of the law of cosines. It's where it comes from. We start with, we get a little bit of Pythag right here, and then our modifier. And our modifier comes from these different parts of these triangles, these two right triangles. So again, to summarize, start out by dropping a height. Label that height H. Height hits at 90 degrees, so we have two 90-degree triangles right here. We'll call one little base of that 90 on the left x, and the base of the 90-degree triangle on the right c minus x, because the whole thing's c. And if we subtract the piece over here that we called x, we get what's left over. We can do Pythag to both sides. Get this for the left side. Solve for h squared. Do Pythag for the other. Do a lot of simplification. And get down to here. Then we'll plug in for h squared from earlier. Things will cancel, and we'll eventually rearrange it so c and b squared are together. That just makes things look nice right here. And then we'll get rid of x by doing cosine. So a couple different steps there. Practice it a lot. Again, draw yourself some triangles, change the letters A, B, and C, what order they're in, and see if you can make something happen here. The key to look for is that the two letters here are matching, and the leftover letters are on the inside. So best of luck.